Hey everybody, this is Shisha. This is yet a new episode of SalesforceWay podcast. Today I'm sitting with a really wonderful guest with me. His name is Uncle Bob, Robert C. Martin. Hello, Robert.
Hello, how are you?
I'm good. At the very beginning of this podcast, I had a chance to talk with another Robert in our Salesforce ecosystem. We talked about clean code. And at the time, we said, okay, you are Robert, they are also Robert, but you're not the author of the Clean Code book. But now today, I have the chance to really to talk to you again. I'm so excited.
Well, thank you very much. That's kind of you.
Yeah, just a little introduction for the minority of people who don't know you yet. So you are the co-founder of cleancoders.com, and you are the author of several really famous programming books, including the Clean Code book, and also you're a public speaker. You go all around the world just to talk about the things you're passionate about, and you are also like the idol of many programmers, myself included. Yes, you are. So Uncle Bob, so today I want to bring you here to talk about the clean code, which has definitely changed the way of thinking about the programming, the way of doing programming for many, programmers around the world. So do you remember when the book was first published? Which year?
Oh, let's see.
It's a challenge to you, maybe.
2000 something or other.
Yeah, it's 2008. It doesn't really matter. Yeah.
I've got a copy of it here. Let's see. All right. Yeah. So I can give you the copyright date. It's 2008.
Yes, that's our original
right?
publishing date. Yes.
That looks like the copyright date, 2008. Yeah. Okay. Yeah.
Yeah, indeed. I'm curious, before 2008, because my programming career started in early 2000s. So there's still a gap for me before 2008. Was it a thing, the clean code? Was it a thing, in the industry? Was people really talking about it?
People were talking about writing code well. You could get hints of that from books that had appeared before. Kent Beck wrote a book called Implementation Patterns. Prior to that, he had written a book called Small Talk Best Practice Patterns. And those were books that were focused on writing code well from a patterns point of view, almost a mechanistic point of view. He would describe certain coding practices, certain coding snippets, and discuss why they were good ideas. But there was no authoritative work on what good clean code was. And that was because most of us did not feel like we had a right to publish a book like this. It had been on my mind for some time, but it takes a very large degree of arrogance to write a book that says this is clean code. And so for a long time, I resisted the idea. And then at some point I thought, well, somebody's got to write this book. And I presented it in the book as, my standards. They don't have to be your standards, but they are my standards. This is what I do. And I had enough experience, I felt at the time, to be pretty authoritative about it. And so I bit the bullet and I wrote the book. I got a lot of people to help me with it too.
How long did it take you to?
Books take me about 3 years to write. Some are a little faster, some are a little slower, but in general, if I start a book project, it's going to be 3 years before I'm done with it. And that's because I will write for a week, and then I will stop writing for 2, and then I'll write for another week and stop writing for 3. It's a very stochastic process. And And of course, real life interferes a great deal. So I would have to travel around the world, and I can't really write much when I'm traveling around the world. And then I would get a spare week or two at home, and I would write a book. I've got a new book on my screen right now. I'm trying to write a little bit into it. But it's hard to find the time. So it takes a few years.
So was it the first book you written?
Oh, heavens no. Oh, heavens no. Let's see. I'll get you the first book I ever wrote. It's very embarrassing. Where is it? Where is it? I know I've got it up here somewhere. The title of the book. Here it is. Yes. Okay. This is a 1995 book? Yeah. 1995. Designing Object-Oriented C++ Applications Using the Booch Method. This is before I realized that short titles are better than long titles. The book is loaded full of all kinds of, Booch diagrams and, lots of designing techniques. And it was primarily about object-oriented design in C++. It sold tolerably well in the 90s, but that was my very first.
Okay. It was the first book that I started to know you. So if we start to talk about the clean code book and the concept, did you have your own definition of clean code? Did you write it in your book? Because I know that you talked with different famous programmers and you put what's their definition. I don't know, did you already come up with your definition as well?
I had my own vision of what I thought should be clean code. And so that's the first part of the book is just, my understanding of what it takes for code to be well-structured and clean. But again, there was this problem of arrogance, right? If it was really common even 10 years ago to not try to assert yourself as an authority. And so I got several other people that I know and trust and like a great deal to put their own ideas in so that the book would be a spectrum of ideas, not just, my narrow view.
Do you have your favorite quotes from those programmers in your book? Or anyone is your favorite?
Favorite quotes from the other programmers. So let's see.
Because at least I love one of the definitions that Michael Feathers put there. It's like, I don't know if you like that one as well.
Oh, yeah. It's one of my favorite descriptions of what clean code is. Clean code always looks like it was written by someone who cares. That's a good one. And that's Michael Feathers' moralistic definition of clean code. And it's a good one because many programmers look at code and realize that the author didn't care about them at all. They only cared about getting that code written and working and not about anybody else. And Feathers' idea is, no, when you read code and you get the feeling that the author of that code cares about you, well, then that's clean. That's good, clean code. My other favorite quote from that particular part of the book was Ward Cunningham. And Ward Cunningham said, let's see if I can pull this out of my memory. Clean code, you are reading clean code when each routine you read is pretty much what you expected. That's how it goes. You are reading clean code when each routine you read is pretty much what you expected. And that was one that took me a long time to get my head around, because when I first read it, I kind of shrugged my shoulders and said, well, Ward, whatever. And then I thought about that for a long time and realized that I had almost never read code that was pretty much what I expected. Usually I'm reading code and going, oh my God, what the hell does this code do? And Ward is saying, no, you read the code and you agree with it. And the information from the code flows into your mind with no impedance. It's pretty much what you expected, and that is good, clean code. Of course, I would expect something profound from Ward Cunningham. Ward Cunningham is the guy who invented wikis and worked with Kent Beck on extreme programming. He's been, this guy in the background for years that almost nobody knows, but he's been remarkably influential.
I see. For many of the young programmers, how do we really know the code is clean? Back in the university time for me is that I thought a programmer, the definite task for a programmer is to get the job done, to make the application work, while I don't really care about the reader. If the reader doesn't understand, then they are not smart enough. That was naively in the early days what I thought. But in your book, you talked about what is the clean code. What are the definitions of clean code? What are those principles of clean code? Could you give us some good examples?
Well, there's a number of lower level principles. The overriding principle is this: you are not done when it works. Getting the code to work is the easy part. Getting the code to read well is the hard part, and the reason you're really hired. It doesn't take an awful lot of skill to cobble together a program that works. You learn to do that in the first couple of years, and after a while you can do that. It takes a fair bit of experience and effort to then massage that code into a state where other people can easily pick it up. Now, some of the mechanics that I talk about in the book are obvious things like, choosing good names. Think about the names. You don't just kind of throw a name out there and then let it stand, but think about names. Keep your functions very small. And by very small, I mean very, very small. Extract functions as much as you can and give them good names. And simple things like that will go a very long way to helping you organize the code in such a way that other people will find it to be pretty much what they expected.
I see. But good namings are difficult. I'm not an English native. Sometimes I'm really scratching my head to think about what names should I put for this variable to make it easy to understand. I don't know is it better, easier task for natives?
Oh, I don't know. Obviously, if you're programming in English and you're a native English speaker, it's probably a little easier. On the other hand, a name, it's very hard, even for a native English speaker. It's very hard to choose the right name. And it's hard because we often don't know what the function we're writing is actually going to do. We think we have an idea, but then we write the function and it turns out to do something different and something more nuanced. And the name isn't right now, but the name is there. And so we let it stand. And it would be better to go back and think about that name, and maybe that will affect the name of the class that you're in, and maybe that will affect the name of the namespace that you're in. The effort of choosing names is one of the most fundamental design efforts that you can engage in, and very often it is that effort of choosing the right names that will profoundly impact the shape of the overall program. There comes these moments of vast insight when you're staring at this code and it just doesn't look right and it doesn't feel right. And you suddenly realize, oh, that thing is not that, it's this other thing. And that changes the shape of 1,000 lines of code around it. And those are wonderful moments. Of course, there's a little bit of effort that's required after that. But it's a wonderful moment because then all of a sudden you can put this code into a shape that makes perfect sense to you, and it's going to make perfect sense to everyone else. And it'll look like it was written by someone who cares.
But I wonder, does it make sense for the managers or other people in the team? Because you've get the job done, it is working, but then you still need to spend the extra time. To them, maybe it doesn't make sense, but to yourself, you understand it's important.
Yes.
But how do I justify the extra time I spend on that?
Yes. Okay. Well, I mean, there's about 8 different things I could say about that. First thing is, how many times have you looked at code on your screen and been significantly slowed down by it? Either because somebody else wrote it and you couldn't understand it, or you wrote it a week ago and you can't understand it, right? And that slows you down. Now, here's the problem with that. That code will slow you down every time you look at it and every time anybody else looks at it. There's a huge magnification effect. Bad code slows everybody down. Good code slows nobody down. Bad code slows everybody down. So you, as the programmer, are making this false trade-off. You believe that you are going to save time by getting it working and walking away and not spending a little extra time cleaning it up. The effect of that, of course, is that you then slow down everybody else on the team forever. And the magnification effect is huge. And what happens to teams, and you've probably experienced this, is that they will start out relatively fast because there's very little code in the system. And then as time goes on, the entire team slows down. All the estimates start to grow. Everybody gets paranoid of touching the code. Every time they touch the code, it breaks in a dozen different places. They have no idea why. They know they're going to be spending massive amounts of time debugging and struggling with this growing mass of unruly code, and everything slows down. And the managers notice that, of course. The managers are all going, well, what the hell happened? You guys used to be fast. Now you're slow. You guys have changed. You guys have gotten lazy. You guys have become bad programmers. And that puts pressure on the programmers to go even faster and make even bigger messes. And the whole thing just goes out of control. Mm-hmm. So that's number one, right? If you take the time, a little bit of time to clean up the code that you just wrote and got working, you will save massive amounts of time tomorrow and the day after and the day after, right? So that's one. But there's another factor here, a much larger factor. You used the term, how do I justify? And I answer that. Why do you have to justify it at all? Why is it anybody else's business? You are the expert. You are the one who knows how to write code. The manager does not. The manager does not know how to trade off good code against bad code. The manager doesn't know what good and bad code is. It's none of the manager's business. That's the reason you were hired. You are the expert. You know how best to serve the company you are employed by. And therefore, you should not ask a manager if it's okay to clean up the code. That is the wrong question to ask. First of all, it's an unfair question to ask because the manager has no idea what that means. Secondly, it's a cowardly question to ask because you are asking the manager to take on the risk that you have decided you do not want to take on for yourself, but you know you should. And so it is an unethical question to ask. It's a cowardly question to ask. And it's just the wrong question to ask. You know how to be professional. Be professional.
Okay. So, yeah, I got the point. I got the point. It takes some time to digest, especially the first time when I hear about this.
Uh-huh.
But does it mean each time when I touch the code, I should spend a certain amount of time to just massage the code a bit?
Oh, very often that's a great idea.
A large chunk of time.
Yeah, no, that's very often a great idea. You bring code up on your screen And you kind of look at it sideways and think, well, I don't really understand it. Maybe I could fiddle with it. Maybe that function's too big. I'll split it in half, change this name, things like that. And once you get it into a position you really understand it well, then you can modify it. It's much easier to modify code that you understand. Now, all of this implies something. If you are going to fiddle with the code, you need some way to keep that code safe, because fiddling with the code can break it, and you don't want to be the one who breaks the code. So you need something that keeps that code safe. And what keeps that code safe is a suite of tests that you have written through significant amounts of discipline, and you can push a button on your screen, and those tests will execute within seconds and tell you that you haven't broken anything. And if you have that suite of tests, well, then you can make any change you want to the code, because you're not going to break it. Or if you do break it, you're going to find out instantly and put it back the way it was. This is one of the big problems. If you want clean code, nobody writes clean code. Everybody makes a mess because it's hard enough to get the code to work. Then you want to make it right. After you make it work, then you want to make it right. But if you don't have tests, you can't make it right because you're afraid. You're afraid you'll break it again. And so the only way to have clean code is to have a suite of tests that you trust with your life. And you have to start those tests right away. You've got to be writing those tests all the time. Have really high test coverage, as close to 100% as you can get it. So that when you push that button and you see it go green, you believe that the system works the way it's supposed to.
Let me ask you two questions. This is more or less Salesforce related. So when we deploy code into Salesforce production environment, there's a rule that your test must cover 75%.
Really?
Or over. Yes.
Wow. Yes.
Otherwise, it will fail you.
Okay. So it's okay then if 25% of the code doesn't work?
It's not about the working. It's just about the code coverage, right?
Well, yes. Okay.
75% of the code.
Fine. We only have to cover 75% because the other 25% is certainly going to work. So I have a problem with numbers like that, right? Numbers like that are completely artificial, and they're always wrong, because the only number that makes sense is 100%. Now, you will never get to 100%, or it's very hard to get to 100%. It's an asymptotic goal. It's one of these goals that you are always pushing upon, right? You need to always make it a little better and a little better. So 75% is a false goal, and it has an extremely bad result. And the bad result is this. If you are going to fail the build because you did not get to 75% coverage, then the programmers, in order to get the build to succeed, will remove assertions from the tests and get the test coverage high.
You know it so well. You know it so well.
Well, of course. I've been programming for 50 years. But when managed, see, the code coverage is a metric that managers should never look at and should not know anything about, because they don't understand what it means. It does not mean that you have covered 75% of the code with tests. It means that you have executed 75% of the code with or without any assertions. And that's a meaningless number. Right? When the pressure is high, programmers will always make the decision to remove a few asserts, get the number high, we'll go back and fix it later. Don't worry, the pressure's on us. And then, of course, you never go back and fix it later. Managers should never touch that metric. It is a very technical metric that programmers can understand and programmers can use privately to understand the level of coverage of their tests. And then this artificial limit of 75 is completely bogus.
I see. But how can I get the test in the good shape? I mean, I have seen projects that we really are in the time pressure. We need to get it to deploy to production. Is there a good principle to guide us? We have a good test that is surrounding our production code so that we are safe.
There are a number of good practices here. Now, the first one is that test code is not, it's not an under citizen. It is not lower class code. Test code is as important as production code, and all the same rules apply. You keep that test code clean. You design it well. And by design it well, I mean you manage the coupling and cohesion of the test code. The test code is part of the system and must be designed to the same standards as the system itself.
Like what you just mentioned, the good naming, small functions, those apply to test as well.
Yes, all of those, decoupling and cohesion and making sure that you're not, breaking 1,000 tests when you touch one bit of the production code. All of those are standard design techniques that you would use in any system without tests, and you would also use them in any system with tests. The other discipline that is extremely helpful is to make the writing of the tests such a high priority that you write them first. You write them before you write the code you are testing. You write a test, and then you write the code that makes it pass. And then you write the next test, and you write the code that makes that test pass. And that's it's a discipline called test-driven development. I'm sure you know a fair bit about it. There's much more I could say about it. But following that discipline will guarantee you a suite of tests with very high coverage that you are never playing catch-up with. You're never trying to catch up by adding a bunch of tests. You have the tests first.
But this TDD practice model does not guarantee your code is your test code is cohesive. It's flexible. When you touch a production code, it won't break.
That's true.
It's just a guiding principle, right? There are the extra stuff you still need to learn when you write code.
Many, many things you have to learn about how to properly write tests, how to properly decouple tests, how to properly design tests. There's many, many things to learn about that. Test-driven development is one of those disciplines that requires many months of experience and practice to do well. It's not one of those things that you can read about and then the next day you're doing it, or at least you're not doing it well.
But does it mean when I do TDD, the test code, the line of test code is more than the production code? Is that almost always the case?
What do you mean by more?
Let's say if my production functionality has 2,000 line of code, then my test code could have been 10,000. Is that typical?
Well, my own experience is that you get close to 1-to-1. 1,000 lines of code and 1,000 lines of tests. Sometimes it's a little less than that. Sometimes it's a little more. It depends on the complexity of the production code. I've never seen it go 2-to-1, twice as many lines of code in tests as in production.
Really?
No, I've never seen that. Usually it's close to 1-to-1 or maybe 3/4 or something like that. And the reason behind that is that the tests themselves, if they are well written, remain very small. There are a lot of them, but they're all very small. The production code grows in a completely different way. The production code grows in this way that promotes generalism and partitioning of functionality. So you get this family of modules and classes on the production code side, and you get this linear list of really tiny tests on the test code side. And okay, maybe it gets close to 1-to-1.
Okay, I see. That's definitely one of the things it's puzzling for me, because when I write the test first, I'm still start to practice TDD. Is that when I see the production code, if I understand the business requirement for a feature, then I need to create maybe 6 or 7 small tests to test the different path of the code.
Yep.
And the need tends to get longer than production code.
Mm-hmm.
Maybe it's just my practice that doesn't, go.
Well, you will see that in very early tests. So as you're writing, you've got brand new code, right? And you're writing some tests, and you're adding code and writing tests and adding code. And yes, the tests will grow larger than the code at first. But then you'll look at this code over here and think, oh man, I gotta split that up. I gotta do something with it because it's gotten messy. And you'll start to pull it apart into little chunks. And those little chunks will begin to grow, and they will begin to accumulate functionality. But your tests will still go through the original classes, the original modules, and access the business rules through those original modules, while this stuff out here continues to grow. And the ratio of tests to production code begins to shift. So early on, you will see that, more test code than production code. But that's in the first 1,000 lines. By the time you get like to 4,000 lines, the shift is gone the other way. Usually.
That's interesting.
Usually.
That's interesting. Okay. I see. So if we talk about clean code, there are code static tools to analyze your code. For those tools, do you think it's important, or does it help much for us to write clean code?
Oh, yeah. Static analysis tools are wonderful things. They can give you hints. For example, just a simple count of the number of lines in a function. That's a really good metric to have. If you've got, if you do the average and you find that the average function is 5 lines, that's pretty good. Yeah. Okay, and then you could find the few. Yeah, 5. That's a pretty big function, right? As long as they're like 5 lines long, okay, that's good. If you get and you find that there's a dozen functions that have 10 or 15 lines, well, then that tells you should go look at those. And a good tool will just give you a list. These 10 here are a little bit larger than the mean. You should look at those. A good static analysis would be cyclomatic complexity, which is usually just kind of a count of the number of indentations. It's almost like that, and that's a useful metric. One of the most interesting metrics that I've run across is a combination between a static analysis, cyclomatic complexity, and a dynamic analysis, code coverage. And this one it's called the CRAP metric, the CRAP metric. And it's a relationship between cyclomatic complexity and coverage. A module that has a high cyclomatic complexity and low coverage is a pretty dangerous module, right? Because it's not covered enough and it's complicated. Now, if it's got low cyclomatic complexity and low coverage, well, that's probably not a big deal, right? Because there's no complexity there. So maybe you didn't even bother to test it. We do not, for example, test our getters and our setters, right? There's no reason to test those. And so they would be low cyclomatic complexity and low coverage.
That makes sense.
It's a real interesting metric, and you can look it up and see. There used to be tools to calculate it. I don't know if those tools are around anymore.
Okay. So in your clean code book, the first half of the book is about those principles, ideas. What are the clean code? How to define, how to make the intangible things become tangible for most of the programmers. And the second part is you use an example, a Java example, to really go through your thought process from a messy, large classes and then refactor it into small. I found that the second part is really difficult to follow, not because you did a bad job. It's just, it's in the book. There's so many lines of code. Maybe if it's in the video format, it's better. That's just my personal idea. So it gives me the hint that it's really hard to write clean code. Not just learning those principles. There are so many. Learning the principles is good, and it brings you really far. But still, if you want to be a great programmer, really know how to do all this stuff easily, that's like thousands or even 10,000 hours of practicing for the programming languages.